Log into AWS Management Console. Click on EC2 Service. From the EC2 dashboard, let me scroll down and click on AutoScaling Groups, which is listed under AutoScaling section. Click on Create AutoScaling Group. Then from the AutoScaling Group Create wizard, select the launch configuration. I am selecting the launch configuration which is just got created in the previous lecture. So that AutoScaling Group will consider this launch configuration at the time of deploying the new EC2 instances in the AutoScaling Group. Then click on Next. Specify the AutoScaling Group name. Specify the group size. This group size is acting as a minimum number of instances must be available in the AutoScaling Group. Then select the VPC, in which VPC the instances has to be get deployed. Then select the subnet, in which subnet the instances has to be get deployed. Let me choose the private subnet, as the instances can be deployed into the private subnet as these instances are not directly accessing by the end clients. Scroll down, click on Next. Let me create a scaling policies. We can mention that the minimum number of instances will be 2 and the maximum number of instances can be 6. That means always AutoScaling Group will ensure that the number of instances available in the group will be either minimum or maximum or between the minimum and maximum based on the dynamic application load. Then we need to configure CloudWatch alarms for scale-in and scale-out operations. Let me click on Scale the AutoScaling Group using the step. Create a increase group size scaling policy. Click on Add New Alarm. Choose the SNS topic from the drop-down so that the AutoScaling Group will initiate a notification to the SNS topic when the scale-out operation is performed. Then, whenever average CPU utilization is greater than or equal to 80% for at least one consecutive period of 5 minutes, then the alarm has to be turned into the alarm state. Once the scale-out alarm details are configured, click on Create Alarm. Whenever the alarm state is in alarm state due to the CPU utilization is greater than 80%, then it has to take the action. Specify the action as add one instance to the AutoScaling Group. Then scroll down. Let me create a decrease group size policy as well. Click on Create Alarm. Select the SNS topic from the drop-down to which SNS topic the notifications has to be get delivered whenever the scaling operation is performed. Then, whenever average of CPU utilization is less than or equal to 20% for at least one consecutive period of 5 minutes, then the alarm state will be turned into the alarm. Once the alarm details are configured for scaling operation, click on Create Alarm. Whenever alarm is in alarm state as the CPU utilization is less than 20%, then it has to take the action. Specify the action as remove one instance from the group. Then click on Next. We can add a notification stating that whenever AutoScaling Group is launching the instance or terminating the instance, or it is even failing to launch or terminate a instance, it has to send a notification to the selected SNS topic. Then click on Next. Specify the tag key value pairs. Then click on Review. Click on Create AutoScaling Group. Now we can see that AWS is creating a AutoScaling group. Once the AutoScaling group is created, we can see that the desired value is now set to minimum value and it is started creating the EC2 instances. Currently, AutoScaling group has 2 EC2 instances. When we look at the activity history, we can see that AutoScaling group has launched 2 EC2 instances successfully from the launch configuration. When we look at the instances tab, we can see that both instances are in service. EC2 instances are deployed as part of the launch configuration by the AutoScaling group. Now we need to associate this autoscaling group with the load balancer. Then only the end clients can start making a HTTP request to access the web application. Hence, let me go back to load balancers. Click on create load balancer. Let me create classic load balancer. Specify the load balancer name. Select the VPC from the drop down in which VPC the load balancer has to be get created, which is VPC. Scroll down and select the public subnet, as the load balancer has to be get deployed into the public subnet. Then click on next. Select the security group which is having the inbound rules allowing the port number 80. Then click on next. Click on next. Leave the default health check settings. Click on next. In the step 5, it is asking to add EC2 instances as a targets. However, as the instances are auto-scaled in the auto-scaling group, we need not to add the instances manually. Hence, I am skipping this specific section. Click on next. Click on review and create. Now the load balancer is being created. Once the load balancer is ready, we need to associate this load balancer to the auto-scaling group. For the association, let me go back to the auto-scaling groups. Select the auto-scaling group, then click on edit. Scroll down. Wherever it is asking for the classic load balancer association, can select the load balancer from the drop down, so that this load balancer is now associated with the autoscaling group and can start identifying the instances which are in the autoscaling group as a targets. If we are using the application load balancer or network load balancer, then we need to specify the target groups for the association. For now, since it is a classic load balancer, we need not to choose any target groups. Then click on save. Once the load balancer is associated with the autoscaling group, let me go back to the load balancer section. Select the load balancer and click on instances. Now we can see that the two instances are automatically added to the load balancer as a targets. Currently the instances are showing as out of service. It would take a couple of minutes to identify the health status of the EC2 instances, and the instances will be turned into in service. Now we can see that the instances are turned into in service. Let me look at the description to see the DNS endpoint created for this load balancer. Let me access the web application by browsing through this DNS name. Now we can see that the web application is up and running. Load balancer is able to distribute the traffic to the backend EC2 instances which are deployed as part of the autoscaling group. And the web application is auto-configured as part of the bootstrap script which we have added in the launch configuration. Once we create a CNAME record for this DNS endpoint in the Route 53 respective zone, then even it is possible to access the website from the custom domain name. I will quickly show you if the CPU utilization is reaching more than 80% threshold, then one more instance has to be get created in the autoscaling group, and that has to be get added to the load balancer as well. Hence, let me log into the EC2 instance. Since instances are deployed into the private subnet, we cannot access the instances directly. First, we need to log into the Bastion host. From the Bastion host, we need to switch to the private instances deployed into the autoscaling group. When we look at the CPU utilization, it is stating that 93% is ideal. Let me run some commands to put the load on the CPU so that the usage will go high. Then we can observe how autoscaling is being performed. Run the stress command. Currently it is dispatching some IO load to the server. Let me run the stress command on the other instance as well, so that the CloudWatch scale-out alarm has been configured that average CPU utilization of the autoscaling group is exceeding more than 80%, then the alarm state will turn into alarm. Then it will notify to autoscaling group that scale-out operation has to be performed and create a new instance. From the CloudWatch dashboard, we can see that the scale-out alarm is in alarm state as the current average CPU utilization is greater than 80%. Let me go to the autoscaling group to see the activity history. When we look at the activity history of autoscaling group, we can see that the desired value has been increased by 1 and the current number of instances in the autoscaling group is set to 3. We can see the instances tab to see how many number of instances are available in the autoscaling group. Currently, we can see that there are 3 instances are available in the autoscaling group. Let me look at the load balancer as well to see if the newly created EC2 instance has been added to the load balancer as a target. Go to load balancer. Let me refresh. Now I can see that one more instance has been added to the load balancer as a target. Currently it is in out of service. It would take a couple of minutes or seconds as per the health check settings to understand the health status of the EC2 instance. Then the instance will be turned into in service. The moment when the instance is turned into in service, that will be participated in the business, load balancer will start distributing the traffic across 3 EC2 instances. Now we can see that the newly created EC2 instance is also turned into in service. As the bootstrap script is added into the launch configuration, the newly created instances can be configured as a web server and can host the web application automatically. Hence the reason the instance is now turned into in service automatically. Let me show you how scaling operation will be performed by the autoscaling group. Hence, let me go back to the EC2 instances. Let me kill this stress command on both instances so that it will not be putting any load on the CPU. As the CloudWatch alarms are configured to have checked the average CPU utilization for every 5 minutes once. Whenever it is found that the usage is less than 20%, then scaling alarm will turn into alarm state. Then autoscaling group will modify the desired value to 2 numbers and it will terminate each instance. Now we can see that scale out alarm is turned back to OK and scaling alarm is turned into alarm state as the current usage is less than 20%. Let me go back to autoscaling group activity history, refresh. From the activity history, I can see that the desired count has been decreased by 1 and currently it is been set to 2 and it is in the process of terminating one EC2 instance. Whenever it is terminating the EC2 instance, there is no data loss as the data has not been saved in the EC2 instance itself. The EC2 instances which are part of autoscaling group is configured only the services and the data must be stored outside of the EC2 instances. Now we can see that the termination has been completed and currently it is having only 2 instances in the autoscaling group. Then let me look at the load balancers. Now we can see that even in the load balancer it is currently having only 2 instances as a targets. This is explaining that how to create autoscaling group and associate the autoscaling group with the load balancer so that it can have autoscaling solution added to the web applications deployed into the EC2 instances. When scaleout alarm is triggered, then it will perform the scaleout operation and create new instances, and those instances will be get added to the load balancer. When scaling alarm is turned into alarm state, then scaling operation will be performed by the autoscaling group and it will terminate the instance and the instance will be get removed from the load balancer as well. As the configuration steps are already added in the user data section as part of the launch configuration, the EC2 instances which are deployed will be get configured as a web server and host the web application automatically. And when it is terminating the instance, there is no data loss as the data is not saved in the EC2 instance itself. The data must be stored in outside of the EC2 instance. That's it for this lecture. I will see you in the next lecture. Thank you.